Today we're going to talk about the different reaction types that we have to know. Now what I'm going to do is I'm going to combine both the organic types of reactions that we need and then the inorganic types that we're going to need to know into one, because there's a lot of overlap and we might as well do them all at once. So for addition, combination, or synthesis, this is going to be I'm going to break this down into two types. There's organic addition, combination, or synthesis. Notice I can use the same word for each, meaning addition is the best word to use because it explains exactly what's happening. Combination or synthesis also means the same thing. Now for organic addition, we need a double bond. That is a requirement. So it could be a double, it could be a triple. It doesn't make a difference. And only one product is formed. So the first one is filled in for us. So take a look at what happens. So the bond between the two H's breaks and one of the bonds between the two C's break. And so that allows one H to attach to one C and the other H to attach to the other. And the reason being, we know the carbons need 4 bonds. And so since they lost one each, they're going to need one each as to make a stable molecule, and that's where the H's come in. And that's basically it. So if we did the same thing for these, you're going to see the bond between the H and Cl is going to break, and the bond between the two C's are going to break, and then the H goes to one, and the Cl goes to the other. So you end up with this. So there is your product. So notice the thing they have in common: you start with 2, you end with 1. You start with 2 reactants, you end with 1 product. I'm going to do the next 2 as well. So for these guys, it's H2O, so it doesn't matter how you break it. You're going to break it up into an H and an OH, and then you're going to break the bond between the C's, and then down here we break the bond between the BRs, and then we break the bond between the C's. One H goes to one carbon, the OH goes to the other, and in this case a BR goes to one carbon and a BR goes to the other. So you end up with this. Now, with these, a common question I get a lot is, does it matter which one the O goes to the OH and which one gets the H? For molecules that are small like this, it doesn't, because whether you put it here or put it here, you just take the molecule and flip it, and it's the same molecule. So that's not going to matter. When the molecules, and then for this bigger molecule, it would actually matter because we would get different products depending on what happens. But because this molecule is perfectly symmetrical and it's 2 BRs either way, it's not going to matter for this one. So you put 4 in a row. Now notice for this last one, I didn't write the H's in. I just didn't, you don't have to at this point. But I did put the BRs both down. It does not matter if you put them both down, doesn't make a difference. They're free to rotate around the molecule. Now, there are instances where you end up making more than one product, because half the time, let's say the OH, in this example, the OH will go to one carbon and the H will go to the other, and then the other half the time they'll flip, and so you end up making 2 products. Half of them are this way and then half of them are flipped. On a small molecule, it doesn't matter. On an asymmetrical molecule, it might. Here's what I'm going to tell you: you're never going to have to worry about that. As long as you know, break the bond and add them to it. They typically, what the regents will do is, if there's more than one potential answer, they accept both potential answers, because trying to figure out which one is the right one or which one comes out more often is is bare minimum a college level organic chemistry problem. And so we're not going to worry about that type of stuff. We just need to know, mush them together, break the single or break the double bond, or if there's a triple bond, you break one of the 3 bonds and drop it down to a double bond. For non-organic or inorganic addition, same idea. You combined 2 or more reactants to make a single product. Now, you don't have to worry about this as much. You just have to be able to identify it. Don't worry about these blank spaces here. That's for a topic that we're going to learn in a little bit called balancing chemical equations. I'm not going to get into it, but basically, here's how you do inorganic addition. You look at it and you say, okay, 2 things, they came together. There were 2 here, they came together. There were 3 here, they all came together. That means it's called addition or combination. Those names should be very obvious. Synthesis is a little bit less. Don't worry about the fact that there's 3 Mgs here and there's only 1 here, and there's or 2 Cls here and only 1 here. That's what balancing actually fixes. But again, we don't worry about that. We're just looking at the general trend. Is it coming together or is it breaking apart? The next one we're going to do, here's some more inorganic addition. They're pretty simple. 2 becomes 1, 2 becomes 1, 2 becomes 1. You get the idea. Now, if you notice, more than one different, here I have S and O2, and they make SO2, and here I have S and O2, and they make SO3. Same thing with the FEs and Os. More than one product is possible, but again, we don't really care about that because it doesn't really matter. It's we just need to know if it's addition or not, and that's pretty much it. Now, substitution is our next one. If you think about the name substitution, think about what's happening in a sports game. When they substitute a player for another, what are they doing? Well, they're trading one player for another player, okay? And so one element replaces or trades with another, and you can get more than, you often get more than one product formed. Well, you're always gonna get more than one product formed, as a matter of fact. So in this case, let's take a look. This H traded places with one of the BRs to make this. Done. Does it matter which H I picked? No, not really. Not at this level. It's not going to make a difference. So you could swap it with this H, this one. Any of the H's were fair game. You just trade them. And that's why it's called substitution. So for you to do one, I'm just going to do the easiest thing. I'm going to switch the H with the nearest CL. And I'm going to end up with this. Done. That's all substitution is. And for the last one, fermentation, we're not going to really draw these out. Fermentation is kind of a memorization one. So fermentation is making alcohol, and your products are always going to be carbon dioxide and alcohol. That's really it. So the alcohol could be anything. The most common, this doesn't have to be this way, but the most common alcohol that we make is ethanol, which is this one. Eth meaning 2 carbons in a row, and then the OL tells me it's an alcohol, so this is ethanol. It does not matter where you put your H or the OH group because it's such a small carbon chain. It doesn't need a number, so that's no big deal. And CO2 is just CO2. And then the sugar is our basic sugar, C6H12O6, but it doesn't have to be glucose. It could be any of the sugars. You know, if you remember from biology, you learned a bunch of different sugars, but glucose is definitely the most common because we're not really, you know, this is a chemistry course. We're not really testing, do you know all the different sugars? We're really asking, can you recognize that this reaction is called fermentation? And so fermentation is really, you know, you take a sugar, you make alcohol and CO2. It's that simple. That's all you need. You can put in the yeast part because we used yeast bacteria to do that in when we do this pretty much all the time, but you don't need yeast bacteria. You can actually, there's other ways to do it using more advanced chemical methods. Yeast is the easiest, which is why that's what we do on a general scale, but you can do it other ways with like temperature and pressure and things like that. But those are the first 3. I'm going to break this video up into multiple segments so it's not too long.